Okay, so this is the incline plane example. Looks like we have someone going down a hill on a sled. So just reading through the top question there. Looks like 30-degree incline sled, but then the key here is ignore friction. Oh, look, 80 kilograms right there. Ignore friction. So we're not going to have a friction force up the plane, which again, there's going to be a zero somewhere, but just remember, ignore friction. It's going to be frictionless. So start with the free body diagram. Um, some of the keys you've seen have had just like a dot with the arrows in it. Remember, and I think it's easier to draw, but you don't have to do it this way. I like drawing the inclined plane, making that little wedge, then making a square on that wedge to set us up. That allows us to draw the arrows a little bit more. Put a dot in the middle, and I'll draw gravity straight down, right? I always do gravity first, F, G, and then we'll always say that equals G times M. In this case, that's 10 times 80 for 800 newtons, right? Keep going. Draw the other forces. We have normal up, kind of at an angle, right, perpendicular to the surface there. That'll be F normal, and that is not equal to gravity because we're on an inclined plane, and they're not the same force. So those are our only two forces. We don't actually need to draw friction. However, instead of doing B over there, where we draw the components of gravity, let's put it right onto the A diagram. So I'll use red again, and we'll have two forces. The first one, I'm going to come opposite normal. I'm going to come back perpendicular to the surface, down into the plane. All right, that's going to be one leg of my triangle. So I'm not going to go all the way down. We're going to keep that shorter than the gravity force. And that's going to be my F. Let's zoom in so you can see it. F, G, Y force. All right. And then we will draw another force kind of parallel to the plane. These are called perpendicular and parallel forces as well. Oh, no, let's make it dashed. Dash, dash, dash. And that force is going to also be a component of gravity, but it's the component down the plane. And so we call it FGX because it's the one that's going to cause that acceleration down the plane. So those are the forces and the free body diagram for that. Next question says calculate the weight of the sled. Well, we already did that because you made the habit of doing that every time you write FG, which is weight. So we'll just say FG equals 800 newtons. But if you didn't do that before, you do it right there. All right, calculate the components of the gravity force. This is where, don't try and memorize this. Go to your sheet. Go to the Unit 2 inclined plane equations and grab the right ones, right? So we have right there from the sheet, FGX or FG parallel, as it says on the sheet there, is equal to mg or gravity, FG, times, in this case, it's sine of the angle. So that would be 800 times the sine of 30, which gives us 400 newtons down the plane. All right, we also have an FGY component. That's going to be FG or mg, which is FG, times the cosine of the angle. And so that's going to be 800 times the cosine of 30 degrees. And that equals 693 newtons. So those are our two components of gravity. Notice neither one is 800 newtons. 800 is what gravity actually is, but the components 400 and 693 are not going to arithmetically add up to 800, but they do add up with a triangle. All right, but those are the ones we can do physics with. We can do our stuff. So calculate the normal force and the acceleration. So we'll split it. Normal force is just going to be balancing our ups and our downs, or our y forces. So that's kind of the y direction there. We'll say our F up must equal our F down. But remember, it's kind of tilted there. That's just going to be normal equals FG Y. In fact, maybe get in the habit of, once you draw the FGY force, you can put the little equals to or congruent signs on each of those two forces to remind yourself that they're the same. But we plug in the number, and then we see that the normal force just equals the 693 newtons there. So that's normal down the plane. So what's the acceleration? Well, that's going to be the x, or what we call the x direction of the plane. And we're going to do that in two steps. We're going to find the net force, which, since there's no friction, it's just that 400, but let's show that. So we're going to say our right forces, or the ones down the plane, minus the left forces. It's going to give us our net force, right? The difference between all the forces gives us our net. In this case, there is only 400 to the right 0 down the plane. That's the tricky part, right? There's no friction, so there is nothing to the left. And so net force must be 400 newtons. That's my net force equals. That is the force that's going to cause the acceleration. So we'll say acceleration, how much? Well, acceleration is F net divided by the mass of the object. So it's going to equal 400 divided by 800, not 800, 80, because it's the mass, not the weight. And that is 5 meters per second squared. So it has an acceleration down the plane of 5 meters per second squared. All right. So now we're going to increase that angle of incline. We're going to make it nice and steep there. And if you want to draw like a picture, that could really help maybe visualize, oh, wow, yeah, there's a lot more gravity pulling it down the hill. So what does the weight do? Well, weight is gravity. That's not going to change. We didn't change the mass of the object, so weight is going to stay the same. The only way to change weight is to change the mass of the object or to put it on in a different gravity field. Normal force. Well, as you get steeper and steeper, the normal force is going to decrease because less and less is holding you on the plane. Less of gravity is acting into the plane, more of it's pulling you down the plane. So because more gravity is pulling you down the plane, the acceleration is going to increase. More of that acceleration or that force down the plane, thus a higher acceleration. And that is a little review of inclined planes.